Welcome to Study Loop.
Okay, so I think the main reason why we think that dust is attracted to clean CDs is because it's so clean, so we see the dust when it gets there. Um, but as far as why it's actually attracted to it, if it is, um, basically what happens is if there's a CD and you wipe it with a cloth, you actually exchange electrons between the CD and the cloth. That means the CD is charged. Um, I'm not actually sure if it's positive or negative, but I would imagine I would imagine that it's positively charged. It's not that it actually matters, it's the same result either way. But if it's positively charged, now let's imagine that there's dust particles floating around. Basically, what would happen with these dust particles is they're all charged neutrally. So basically, that would mean that they experience electrical forces from these charges. So it's not that the net force. All right, I guess you got to think about it in terms of these dust particles are free to move and they're free to kind of rotate, and the charges within them are free to move. So, for instance, let's talk about this particle right here, this one that I've just marked red. If the CD is charged positively, then the negative charges come toward the positive charges, so they'll be on this side of the particle, and the positive charges will be on the opposite side over here. Well, but that means that the negative charges are closer, the positive charges in the CD, than the positive charges um, on the dust particle. So that means that the attractive force, the electricity on the front of the dust particle, is actually stronger than the repulsive force on the back of the dust particle. So the net force on the particle is actually, toward the CD. And that would be the same logic if the CD were negatively charged.